Hello students, today we will continue with the lesson amines, the last part of the lesson amines. Reaction of amines with the nitrous acid. Nitrous acid is an unstable acid which is prepared at the time of reaction by adding aqueous sodium nitrate to hydrochloric acid. Aliphatic primary amines on reaction with the nitrous acid form aliphatic disonium salt, which is an unstable intermediate which decomposes on reaction with the water to form the product alcohol and nitrogen gas is liberated. The general equation can be written as RNS2 plus HNO2. HNO2 is nitrous acid at ice cold temperature, that is 273 to 278 Kelvin, forms Rn2 plus Cl minus, that is alkyl disonium chloride, which decomposes in presence of water to form alcohol and nitrogen gas is liberated. Aromatic primary amines react with the nitrous acid to form disonium salt, which have more stability at 273 Kelvin. It is aniline plus nitrous acid gives benzene disonium chloride. These aryl disonium salts are resonance stabilized and is used for the preparation of variety of product. Reactions of aryl disonium salt. Aryl disonium salt gives two types of reaction, that is reactions involving displacement of diso group and reactions involving retention of diso group. First, let us see reactions involving displacement of diso group. In these reactions, the diso group is replaced by another atom, another univalent atom or group with the liberation of nitrogen gas. First one is Sandmeyer's reaction. In Sandmeyer's reaction, the diso group is replaced by chlorine, bromine or cyanide group. For this, the aryl disonium salt is treated with cuprous chloride and HCl, then it is forming aryl chloride. If it is treated with the cuprous bromide and HBr, it is forming aryl bromide. If it is treated with the cuprous cyanide and KCN, it is forming aryl cyanide. So, such a copper ion catalyzed reactions are called Sandmeyer's reaction. Next, Gattermann's reaction. Gattermann's reaction is a modification of this Sandmeyer's reaction. That is, cuprous salt is replaced by copper powder and halogen acid. Aryl disonium salt, when treated with the copper powder and HCl, it gives aryl chloride. That is, diso group is replaced by chlorine. If it is treated with the copper powder and HBr, diso group is replaced by Br, so that aryl bromide is formed. Next, iodo-arene formation. That is, aryl disonium salt when treated with a potassium iodide, then diso group is replaced by iodine and iodo-arene is formed. Next, mild reduction reactions. That is, aryl disonium salt are reduced by hypophosphorus acid, H3PO2, that is hypophosphorus acid in presence of water. It is forming aromatic hydrocarbon. That is, diso group is replaced by hydrogen atom. Or if it is treated with alcohol, then also it is reduced to aromatic hydrocarbon. Next, phenol formation. Aryl disonium salt when heated with water at 283 Kelvin, then diso group is replaced by OH group, so that phenol is formed. Next, reaction with the fluoroboric acid. Aryl disonium salt when treated with a fluoroboric acid, HbF4. HbF4 is fluoroboric acid. It forms a precipitate of ArN2 plus BF4 minus, that is disonium fluoroborate. If it is heated, disonium fluoroborate, if it is heated, it gives fluoroarene with the liberation of nitrogen gas. If it is heated with aqueous sodium nitrate in presence of copper, it forms nitroarene with the liberation of nitrogen gas. Second type of reactions of arene disonium salt, that is reactions involving retention of diso group, which is also called coupling reactions. Here the disonium salt react with reactive aromatic compounds like phenols, aniline, etc. to form strongly colored azo compounds, that is ArN2 Ar. This reaction is known as azo coupling reaction. For example, when benzene disonium chloride reacts with a phenol in mild alkaline medium, it gives para-hydroxyazobenzyne, which is an orange dye. The equation is benzene disonium chloride is reacting with a phenol. Here the hydrogen atom of phenol combines with the Cl to form HCl, and benzene disonium group is get attached to this phenol. So it is forming para-hydroxy. This is para position, para-hydroxyazobenzyne is formed. Second, benzene disonium chloride reacts with the aniline. Benzene disonium chloride reacts with aniline in presence of mild alkaline medium. It gives para-aminoazobenzyne. This is para-aminoazobenzyne. Here also hydrogen atom from amine and the Cl is removed as HCl, and the benzene disonium group is get attached to aniline, so that it is forming para-aminoazobenzyne, which is a yellow dye. So this reaction is the basis of azo dye industry. Next, Hinsberg test. Hinsberg test is reaction of amines with arene sulfonyl chloride. Benzene sulfonyl chloride is C6H5SO2Cl. So it is also called Hinsberg reagent. So when primary amine, for example ethylamine, reacts with benzene sulfonyl chloride, it forms N-ethyl benzene sulfonyl amide. Equation: benzene sulfonyl chloride, primary amine ethylamine, it is forming N-ethyl benzene sulfonamide, which is soluble in alkali. You can see the ethyl group is attached to nitrogen atom, so it is called N-ethyl benzene sulfonamide. Second, secondary amine, for example diethylamine, reacts with the benzene sulfonyl chloride to form N-diethyl benzene sulfonamide. Here you can see the equation: benzene sulfonyl chloride reacts with the secondary amine, that is diethylamine. It is forming NN diethyl, nitrogen atom, two ethyl groups are attached, so it is called NN diethyl benzene sulfonamide. Electrophilic aromatic substitution in aromatic amines. The amino group is orthopara-directing and strongly activating group. Thus, aryl amines readily undergo electrophilic substitution reaction. First one, bromination. Aniline reacts with the bromine water at a room temperature to give a white precipitate of 2,4,6-tribromoaniline. The equation is aniline plus 3 molecules of bromine water. It forms 2,4,6-tribromoaniline. Here every available ortho and para position is halogenated by bromine. Now the second type of electrophilic aromatic substitution reaction is nitration. Direct nitration of aniline gives a mixture of ortho and para nitroanilines in acidic medium. Amino group is protonated to form anilium ion, which is meta-directive. So aniline on nitration, it is forming para-nitroaniline, meta-nitroaniline and ortho-nitroaniline. However, to get para-nitroaniline as the major product, NH2 group is first protected by acetylation, then nitration is carried out and the amide is hydrolyzed. So the equation you can see, first aniline, that is the amine, is acetylated in presence of pyridine to form acetanilide, which on nitration it is forming para-nitroacetanilide. Para position NO2 group is substituted, which on reaction with the water or which on hydrolysis it is forming para-nitroaniline. Sulfonation reaction. Aniline reacts with concentrated sulfuric acid to form para-amino benzene sulfonic acid, that is called sulfanilic acid as the major product. The reaction is aniline reacts with concentrated sulfuric acid to form anilium hydrogen sulfate, which on heating at a temperature of 453 to 473 Kelvin, they producing para-amino benzene sulfonic acid. It is otherwise called sulfanilic acid. Here we can see para position, amino group is substituted, so it is called para-amino benzene sulfonic acid. This sulfanilic acid can exist as a salt, so it is called dipolar ion. You can see polarity on both the ends. It is otherwise called Switter ion. It is produced by the reaction between the acidic group and basic group present in the same molecule. Here in sulfanylic acid, this is the acidic group and this is the basic group. So reaction between SO3H and NH2 group will produce this Switter ion or dipolar ion. So students, today's session we have seen the disonium salt, the important reactions of disonium salt, that is reactions involving a replacement of diso group and retention of diso group. Then Hinsberg test, and lastly electrophilic aromatic substitution reactions, bromination, nitration, sulfonation, etc. So students, please make the notes for this topic and study. So we come to the end of the lesson, amines. Thank you.